Hey gang, it's Mr. Schmidt for SMT Environmental Science, September 28th with a recap of our open-closed systems discussion we had. So first off, we're going to be talking about our open-closed systems, then I'll go over a few examples in the assignment, and then we'll go into a preview of what you need to be ready for the next class. So we're talking about open and closed systems in terms of matter and energy. So our goals are students will be able to explain how matter and energy flows through a system, and students will understand the difference between open, closed, and isolated systems. So here we see a little model of something like a ball or paper airplane perhaps that started at a great height, and then the paper airplane comes down. Energy from that height gets translated into energy of motion. So we call it potential energy, kinetic energy. And this model is based on a physics assignment. We're in environmental science, so we're going to focus not just on that energy or not just on that mathematics, but more on the systems themselves. So what we're looking at is the conservation of energy and matter. Energy and matter cannot be created nor destroyed. They can only change forms. When we're talking about energy, it's the ability to do work. It can be classified as potential energy, which is stored, or kinetic energy, which is some energy from motion. Okay, we're going to go into a lot more details along that way. And the corollary to this is that work is the change in energy. One of the first great experiments that started this was a scientist by the name of Joule found out that if you took masses or rocks or something heavy and it slowly fell, it had to release its energy. If you didn't let it go fast, like it wanted to, then that stored energy in its position, its potential energy, would be released into some other format. And if you could, through some strings and pulleys, make all that energy turn a paddle, then the paddle would push water and push energy into the water by stirring it and causing a lot of turbulence. So with this dueling apparatus that is nicely balanced, so they both fall down, the water gets stirred up, and they had it all nice and insulated and covered so no heat or energy could flow out of it. And the thermometer showed that if the energy is flowing in through the paddle, then the thermal energy will increase, it'll get warm. Okay, and because of that, we call the measure of energy joules. So the easiest one to calculate is the one I showed before, the potential energy, because when we looked at this graph, the important measurement is height. So potential energy is the potential gravitational energy is the first one we study, which looks at mass in kilograms, gravity on Earth, which is 9.8 meters per second squared, or close enough for us to 10 meters per second squared, and then the height that we measure in meters. Okay, so that was part of the reason why when we did the paper airplane lab, I wanted to see things like a diagram, like how far, how high was your paper airplane when it started, because that gave it some potential energy. And then hopefully in your discussions or procedure, you talked about how fast you threw it, because that gave it kinetic energy. And those two things combined really influenced how far your airplane went and how much time it spent in the air. Okay, now we're not going to do much of the calculations with. That's just a benchmark of one form of energy and how it's calculated. What we see is there's lots of forms of energy. Okay, so like throwing the paper airplane, that's a mechanical energy. A big one we're going to study a lot in environmental science, starting with today, is sunlight, a form of radiant energy. Okay, and then thermal energy or heat, and then wave energy, electrical kinetic, which would be like electrons flowing through a wire, and electric potential, like it's sitting on the top of a surface, like an electric shock is about to happen. Magnetic potential, so there's electrical and then there's magnetic. So like if you had two magnets sitting next to each other, they want to snap together, but you're holding them there, and based on their position, they have some energy, and then you let go of them, they snap together. Okay, so that's magnetic. Then elastic potential, which is sometimes called spring energy, Okay, so if you compress a spring or something elastic, it's going to want to spring into a different shape, and that's a different form of potential. And then the one we talked about, gravitational potential energy of the paper airplane. Okay, another key one for environmental science is chemical potential energy. That might be sugars and fats, or it might be inside a battery with the lithium and the other ions, and how they are poised to react for chemical potential. And then kind of turning the full loop here, nuclear potential, obviously it's not something we're going to study directly in the classroom in terms of a nuclear reaction, but the fact is when we look at the sun is this giant ball of hydrogen, and that gravity is pushing these hydrogens together, and we get what's basically a thermonuclear reaction as the hydrogens bonding and forming new molecules or new atoms, helium atoms. And then when they do that, it releases the radiant energy and the thermal energy as a part of that. So as living things on Earth, we know all of our energy starts from the sun. It starts from that nuclear reaction on the sun. And then the electromagnetic waves, the radiant light energy hits Earth, producing thermal energy and all those other processes and life processes that we're going to study as a part of the different biomes. So energy is that anything within that list. States of matter, people are very good at identifying examples of solids. Okay, so when we're talking about something moving in or out of a system, like in or out of you, okay, we can think of one human as a system. Okay, and we're going to define systems all sorts of different ways. Okay, but if we just think about you, okay, so you ate lunch, so you took in solids, okay, and then you had something to drink, you took in liquids, and then you were breathing, so you took in gases, and then you're also breathing out, so you're letting go of gases, and you also went to the bathroom, so you're letting go of liquids and solids. Okay, so those are all things flowing in and out of your system. Okay, now plasma is the fourth state of matter, which happens on the sun or in the sun, and also in lightning bolts or some other high energy positions. Okay, so let's go. So we don't have to worry about that. You're not breathing in and out plasma. Okay, it's not directly in most environments. Okay, it is in the sun. So again, that is an important part of environmental science, but the plasma itself tends not to flow in and out of systems that we study. Okay, so when we're looking at solids, we can look at these states of matter and also think back to the forms of energy we had too, because the state of matter is very much dependent on its thermal energy. So if we think about ice, it starts off as a very cold solid, and the atoms and the molecules not moving very much at all. Okay, and then as you heat up water, the different hydrogen and oxygen start to vibrate and shake and twist depending on how you're exposing them to energy. Okay, and then as you heat it up more and more, the ice crystals break down into liquid water. Okay, again, the weight or the mass of the water has not changed. Okay, the volume might have changed, which is why cooks and chefs so often measure things in mass rather than volume, because your volume can change as you go from ice to water. In fact, as you heat up water from 3 degrees Celsius all the way up to 99 degrees Celsius, it's going to keep expanding ever so slightly until you hit 100 degrees Celsius, and then while it's at 100 degrees Celsius, it's going to translate from those liquids, as again, those molecules are sitting in water, vibrating. You hit it with more and more energy. Okay, it can be from like a fire or a furnace or your stove, or just like Joule did, it could be from paddling. You just keep giving it more and more energy. Eventually, those water particles, those H2O molecules are going to separate from each other, and they're going to form gases, and then they're going to be up in the atmosphere or in the airspace of the canister or wherever they are. Okay, until you've boiled off all the water and all of it's moving around with high energy, okay, taking up a lot of space. All right, and then as you cool it, you'd go through the opposite process. The gases would condense into liquids, the liquids would condense into solids, okay? So that is the phases of matter we're gonna be studying here. But that means when we're looking at different systems, if they say, does matter go in or out? It can be breathing, it can be oxygen, it can be carbon dioxide, it can be any of those gases. It can be drinking water, okay? Or it can be taking in solids or giving off solids as well, okay? So these are the things we need to think about as we go into the assignment of the different things that can flow in or out of a system. Either any of these will be examples of matter, or looking back, any of these will be examples of energy, okay? Because when we look at systems, we're going to categorize them based on energy and matter. So open systems, remember we said you as a human being breathe in air, oxygen, and breathe out carbon dioxide. So matter is coming in and out of you in the form of a gas, okay? And then you also eat. So not only are you taking in the matter of the food, but you're taking in the chemical energy embedded in those molecules, okay? And the sugars and fats and proteins. And as you digest that food, you're moving that energy in, and then one of the first places it goes into is the motion within your body, which you're warm-blooded, so all your cells and all your muscles and everything are moving, and that's generating heat, and that creates thermal energy. And then if you get up, you have kinetic energy. If you talk, you have that wave energy, okay? So there's all sorts of different forms of energy that your body can produce or generate, okay? But what that means is if both matter and energy are coming into your body and matter and energy are leaving your body, then you are definitely an open system, right? As opposed to a closed system where something like your cell phone, hopefully your cell phone isn't taking in a lot of stuff and it's not spitting out a lot of stuff in terms of physical matter. There's no like liquids oozing out of your cell phone, okay? But you might need to plug it in, and you need those electrons to move back and forth and load up into your cell phone battery. And then you turn it on, and all this light comes off of the screen and it releases energy. So your cell phone would be a closed system, okay? Like I said, you're not going to feed it a sandwich. You're not going to put water into your cell phone. It doesn't matter if it has air or not. You're not going to suffocate your cell phone, okay? The only thing it needs is that electrical energy coming in, and then it can produce light and sound and motion based on that stored energy inside the system, okay? All right, and then the extreme is things like, well, I don't know if we ever get perfectly to an isolated system, but if we look at something like a hydro flask, okay, you put some hot water in your hydro flask and you put the lid on, okay? If it's a double-walled hydro flask, there should be a gap in between the two walls, and there's no place for the energy to flow from one to the other, and the lid's on tight, so the water can't go in or out, and now we have an isolated system. Okay, so let's take a look at that assignment and how do we apply those. Okay, so you find the assignment here, okay, you click on it, you save it to your Google Drive, and then you say you're going to open it with Kami. And we get started. Feel free to take a lot of screenshots as you're working, because Kami does have a possibility of losing material, and if you need to turn in pictures, you can have it. Or the best case is you have a paper and notebook, and you just do this on your paper and notebook and take a picture. I'm always in favor of doing it on paper. It's the best way to have it, to store it and remember it. But it's easiest to deliver to you online. And if you want to do it online, I'll accept that. All right, so I said I'd do just a couple examples here. So the Earth. Let's start with, we'll start with one we just talked about, the hydro flask. Okay, is if the lid is on, does any of the matter flow in or out? Hopefully none. Okay, which means we can say, is matter crossing the boundary system? No, I put the lid on. And then you can say, well, if the lid's on and it's a good hydro flask, can any of that thermal energy flow in or out of the hydro flask? Well, not really. Okay, which means we're going to have nothing here as well. Okay, and then our text box for our last one here. All right, so no energy is moving across the boundary, no matter is moving across the boundary, therefore it's isolated. Okay, so each system is going to have its own definition of what the boundary is. It's whatever the edge is of that system. Okay, all right, now the animal cell is just like the human. Okay, what do animals need? Okay, they need air, they need water, they need food. Okay, all of that is matter. Okay, a lot of people want to put air over here. That is not correct. Okay, air is not a form of energy. Air is a form of matter. So let's make sure we're getting that right. Air goes over here. So yes, matter is crossing the boundary. Okay, and then what type of energy is involved? Well, we have chemical energy in the form of food. And we have thermal energy because you are giving off heat, okay? And then we have kinetic because you can move, okay? So those are some of our forms of energy here, okay? So that means that this is a yes here too. So is energy crossing the boundary system? Yes. If you're looking at one cell, okay, it takes in water and oxygen and it gives off carbon dioxide and waste, okay? And if it's taking in that energy, it's within those sugars or carbohydrates that's absorbed across the cell wall. That is not only matter, but there's energy bound up in that, okay? And then it releases it in the forms of heat and movement, okay? Which means if we come over here, yes to matter crossing, yes to energy crossing. All right, so where was one that was closed? Okay, so there are a couple arguments, or like there's different ways to discuss this. In terms of Earth, if we think about the outermost atmosphere as the boundary for Earth, not much matter is coming in here. Okay, not much, maybe meteors. So I'm going to say really there's not any matter that comes from space and hits the atmosphere. Earth's total mass is pretty stable. Okay, maybe a little hydrogen's boiling off the top of the atmosphere. Maybe a meteor hits it, but really, for our purposes, no, nothing's crossing the border or the boundary between Earth's outer atmosphere and space. So energy, well, any given moment, half of the Earth is facing the sun. So we have radiant energy hitting this. Okay, and then there might be some thermal energy of things heating up and cooling down as well. Okay, so that means that yes, we have energy crossing the system, and we have one yes and one no. That is a closed system. Okay, so that is the process you're going to have to go through to answer this. Yes, you do need to give examples here and here. Okay, so make sure you fill those out and you answer them for tonight's homework. Okay, other things to note as we're wrapping this up. Okay, Wednesday is when I'm going to start calculating progress reports. So make sure all assignments and late work and corrections and grade defenses have been turned in for that. And then the second thing, on Thursday, we're going to start talking about the bottle biosphere, okay, which is this assignment. You're going to have to, most importantly, get some plastic bottles, okay? And then hopefully we can find some seeds or some plants on the side of the road or sidewalks that we can use to add to this, okay? If your parents or your neighbors or someone have some grass seeds from doing their lawn, that would be great to add to that. We are going to be doing 3 different levels, so if we can get lots of different seeds that grow relatively quickly, that's going to make things go better. Okay. Again, this can be planting soil or it can just be dirt from the backyard or something like that. Okay. Directions are found here. We're only going to do page 1. We're not doing page 2 with the animals. This just gives us an idea of how we're going to build the plastic bottle containers. Okay. And then where do we go? Okay. And that will get us through the end of this week. And then next week, we're going to put everything together, find a spot for it, and start taking notes. Okay. But right now, you need to start looking for these materials so that if your parents are already going to the store, they can get it. If you're talking to your neighbors or your extended family, you can ask them for some of these supplies. Or if you see something going to the recycling, you can grab it now before it goes out to the garbage. Okay, all right. So with that, I think we can finish up. We've talked about open and closed systems. We've filled out some examples of the scenario, and we're getting ready for Thursday. All right. With that, have a good day.